pricing influences architectural choices. It equips architects and engineering leaders with practical principles for building AI applications that are scalable, cost predictable, and economically sustainable. And to present this session, on stage we have Mr. Narayanan Jayaratchagan, a Senior Director of Application Engineering at Tiger Analytics, a leading AI-driven enterprise solution. With over 3 decades of experience across Cognizant, BI Worldwide, and CGI, he is a seasoned technology architect and a polyglot programmer, an author, and an avid cyclist. Over to you, sir.
Hello. Can you all hear me at the end? Okay. Good morning, everyone. So, by practice, I am an architect, and I'm going to talk about economics today. So, if you are wondering what does an architect have to do with economics, you will see how I'm changing my role as an economist in the new era. So, and again, I think the previous session was about scaling, and he mentioned there are about maybe 5–10% of enterprises are able to scale AI applications. And what are the challenges in scaling is something that I would allude to as part of the session that we go through now. So, see, scaling has been something that we can do technically, and the major premise of the discussion that we are going to have is how can we sustain, because we don't have infinite amount of money to spend on scaling things, right? So how do we make things more sustainable while we want to scale at the same time? That's going to be the focus of the session. Before we get into that, let me start with a quick quiz or a set of questions. So, familiar scenario, right? I think since most of the AA engagements start with MVPs or pilots, 2 common questions that you would get, especially when you want to scale: what happens when the user base doubles? Does the cost double? No. Okay. So what happens? Is it going to be pretty flat? Depends. Okay. You have to give an answer. Depends is not an answer. Okay. And what about the first question? Is the cost for 2 identical requests the same? No? Okay. We will find out as we get in, right? Okay. So, as I said, the architect's role in the new AI era is becoming more of an economist or enabling the economics of the solution rather than just staying more technical, where we talk about, hey, how do I bring in scale through horizontal scalability or vertical scalability or whatnot, right? So how do we use an economic lens and make the AI products more profitable and cost more predictable? And the whole I'll just try and summarize what I'm going to talk about. All of us know about this happy path, right? We start with initial proof of concepts, which are almost success in all cases. But what happens when we kind of move from the initial success that we had in pilots and we try to scale, especially what happens when we keep adding more users? And the users are not really going to be behaving like what you had as part of a typical pilot, because the pilot users are going to be very tech savvy, and they would really be knowing the set of use cases that you are looking at, and they may not really be the actual users, or the real problems may not surface during the pilots. And what happens in these cases is the moment you see cost going up and margins going down, we kind of start looking into, hey, is there a problem with the pricing strategy? But the real problems are not in the pricing strategy, and the real problems lie with the solution architecture and the design that has been put in place. And that is the core premise of my presentation today, where we will talk about how do we really bring in the economic control plane as part of the design, so we are able to make the solution economically viable. So if you are trying to compare AI to the utilities like electricity and other things, the cost needs to come down to a level where it is sustainable. And that can happen only when the solution is being looked at from an economic lens from the very early stages of design. Okay? So what I did, and in fact this is something that I keep doing as part of both my job as well as personal interest, I look at public case studies where we get to see both successes and failures. And this particular case study from Cursor AI stands out because of the recent thing. It happened somewhere in the middle of 2025, where they came up with a pro user license where they said, hey, it is unlimited, $20, and you can use however much you want. But it ended up as a real challenge because of multiple reasons. Number one, they did not really understand what it really means for an unlimited usage, especially when it comes to working with the agentic solutions. And they were relying on a number of LLMs and the providers like Claude or OpenAI suddenly changed their pricing model, which also contributed to the challenges that they had. What really happened was they had to roll back the pricing after the cost started going up, and it wasn't sustainable. And the real problem of going back and taking out or saying that, okay, hey, I gave you unlimited, but I'm giving you 20 rupees back, and you are not going to have the unlimited plan. There is going to be a cap applied, right? The real challenge is whoever signed up is not really going to be happy, and they lose the trust on the service. And so why is such things happening? And that is because the real challenges, especially working with the AI-based solutions, are pretty different from the cloud SaaS-based models that we are used to in the past 10, 15 years, right? And what are those differences? We will look into that. And I do have a few more case studies, and most of these are public ones. These kind of give you a glimpse of why things fail, especially from a cost and pricing standpoint, right? So, and this includes case studies, both the pre-GenAI and the GenAI worlds as well. So if you look at the IBM Watson case study, that is a typical one which was there in the past, even before GenAI became a real thing, right? And the real problem with Watson's adoption was it was a healthcare use case where it had to depend on human to judge and say whether the solution or the recommendations that come from Watson is right, and would the doctors really go for it, right? So bringing in a human into the workflow really has costs that are not sustainable. That was a major problem with the Watson one. If you look at the other ones, which are primarily the GenAI based use cases, the context length or the prompt lengths and things that kind of go in as part of every interaction is really going to have an impact on the overall solution. And this is a major reason why the pilots succeed, wherein the real scaling becomes a challenge on the economic side of it, right? And if you look at a number of providers who are providing wrappers around the LLMs from OpenAI or Claude and others, they also don't understand the kind of impact it would have on the token pricing and other things, because they act more as pass-through layers, and they are going to be dependent on the actual intelligence providers, which becomes a challenge, right? And now, if you look at the agentic solutions, doom loop is a bigger challenge because if you just let an agent keep retrying to get to a level of confidence that you are okay with, it is going to be a never-ending loop, and there is going to be cost associated with every call that happens, right? So, the case studies aren't just about what failed. In fact, if you look at the recent 2 years, there are a number of startups which have been able to look at the failures from the past, and they have actually put in solutions that addresses the challenges. And if you look at the solutions, those solutions are primarily architectural in nature, and it is not a change to the pricing strategy or a pricing model done by the finance teams. And that's the... So first thing all of us need to understand is the world that we have inherited from the past. When I say past, I'm referring to the traditional software development era, where we had the marginal cost as pretty much zero, which has been an assumption that we inherit, and we think it is the same, and it would hold for the intelligence era as well. And if you look at what happens when it comes to AI era, the cost surface is totally unpredictable. And this is one thing where it kind of really goes for a toss. And the biggest challenges are that this is something that happens only when you start scaling. You don't realize all of this, and that is where this pilot illusion comes in, right? So when we are in pilot, what we do, we know the use cases, we know what exactly to test, and pilots are most probably technical proof of concepts rather than giving you a guarantee that it is really going to be working for all the different workloads and all different user groups. And a key that we definitely forget is the fat tail users, especially users who are really going to stress your systems, right? And that is a major thing that has actually been causing a lot of trouble for the pricing or cost-related failures. So one thing that I did was, hey, so the symptoms are the ones that most of the leaders see or the finance team looks at, right? Margin erosions, unpredictable spend, or pricing pressure. Hey, why are you charging me so much? Can the price be reduced and all of that? That is what everybody at the leadership level sees. But if you try to kind of trace it back, the immediate reasons why you have all those symptoms that you are observing are primarily because, hey, you have an infinite doom loop that is going on that keeps trying multiple times, and there could be tool calls that are kind of exploding, or there is a human intervention that is required because the use case is for a domain where the cost of error is very high, for example, healthcare, and a decision cannot really be made by the system alone. It requires human intervention. So these are things that actually escalate the cost, amplify them, but why these things happen? If you look at it from an architectural perspective, because we treat variable costs as fixed, because we made assumptions that were true in the typical traditional applications that weren't really based on the kind of AI/ML models that we currently have, right? And these are the most common root causes that comes at the architectural level. And if you go down to the zone 0, which are the causal primitives, which primarily talks about, hey, cost is not even considered as a primary or a first-class citizen or a non-functional requirement, and we have been focused more on looking at the technical challenges and proving that something is possible, right? So now, if you look at again, the point is, whatever economic pain that you see on the downstream is caused by the upstream architectural choices is the core message that I want to emphasize, right? So next, what was happening in the cloud era, it was predictable bills because the workload patterns were very predictable. If you have hundreds of users, most probably the workload that they would have would pretty much remain the same, and it wouldn't vary too drastically between the users that you have. But when it comes to the intelligence, the cost curve becomes non-linear. And this is, see, when I say non-linear, the non-linearity is going to be varying by a wide margin, and that is what leads to all the cost escalations and the unpredictability of the spend that happens. And other factors which are primarily going to be, okay, hey, we will look into these things at details in the next one, but the core idea that I wanted to highlight is we need to look at what is the total cost of intelligence, and that is way different from just the infrastructure cost that we used to account for when we were working in the cloud or SaaS-based solutions. So it is not just the infrastructure cost where you can go to the cost calculator provided by your cloud provider and say, hey, this is what it is going to cost, because the cost surface is unpredictable for AI workloads, right? And another point is, see, when it comes to AI, the current pricing is primarily based on proxy metrics, and these are not really translating, or they are not priced for the value that we would really be looking at from a domain perspective. Say, for example, if you look at a customer support executive, it could be a case closed. Or if you are looking at claims adjudication, the number of auto adjudications that happen, those are the things that provide value. And we primarily look at productivity and efficiency as the key value enabler from a perspective. But there are a number of other things, and also the most ignored one is the strategic options that you get more from a future things that it can help you solve, right? So now with this, what I wanted to kind of look at from for the next 5-10 minutes would be primarily, hey, how do we address the challenges that we looked at so far? Number one, architectural bedrock, where look at the different layers that makes up the entire solution. If you look at the solution that you have, the experience and the application is where value is perceived, right? So my experience of cursor is going to be based on, okay, hey, does it allow me to do what I want without interruption? Or does it come and say, hey, you have exceeded the number of requests that you can make today, come back after 24 hours. If that is the experience that I'm going to get, I'm not going to be willing to continue with that kind of a service, right? But if you look at the actual cost is being incurred at the layers that are below the application level. Intelligence, data, and the platform is where the actual cost really happens, but the value is perceived at the top layer, right? So now, if the user is perceiving the value differently from how the cost is being incurred, how do we kind of get to a situation where we are able to bring in traceability and tie the cost to the value, right? So the first thing that we need to do, and this is an area where I don't think most of the enterprises do a good job at this point, making cost legible across the layers. So how do I know, hey, what am I spending at each of the layer, at each of the component that makes up my solution end to end? So how do I ensure I get the right set of telemetries and be able to say, yes, this is what is really happening, and be in a position to measure at an individual user and tenant levels. So I would be able to use that to predict and come up with better forecasting of the spends that I would have, right? So that is number one. Number two, we looked at some of the challenges, especially from the case studies that I had put up in the earlier one, right? So bounded autonomy is something that has to be part of the design. So let's say you are bringing in or building an agentic solution. How do you put a limit on the number of tries or number of retries that is going to happen, and how do you decide whether a confidence level is good enough for you or not? And all of that needs to be part of the solution, and it also needs to be looking into the cost budget aspect of it, right? And if you look at one anti-pattern is we always go for the best model that is available. And I don't think that has to be happening for every situation. So you should be in a position to pick the models that are low cost. If the problem that you are trying to address can be addressed by it, if the confidence level that you are getting from the response is not high enough, you kind of route it to another high cost frontier model. So those are things that we should be able to bring in more at a solution design level, and these are not typical AI problem. These are architectural and design elements that we need to address from a design perspective. And the same with the, let's say you are in a situation where you have exhausted your quota, or you are in a situation where your infrastructure is not going to allow you to take more requests. How do you gracefully degrade? And how do you meter the cost? Because you really need to look at tiering rather than going with the seat-based pricing or unlimited models, right? So these are definitely the design elements that needs to be put in place so you can be resilient from an economic perspective, okay? And next one, this is closely related to how AI value realization translates to something that is closer to the user and the domain, right? So if you look at a common challenge that we have today, and even in one of the case studies, Devin AI, they talk about agent unit forecasting. So they say, okay, if you use 1 unit of this agent, you pay $2.25 or whatever, right? But that doesn't really translate to anything from a domain. Say, for example, if I am an executive who works on a healthcare claims processing, for me, adjudicating a claim is a thing that really provides value and makes sense, rather than saying that, hey, you pay $2.5 if you use 1 unit of this agent for whatever process. So how do we move from the old metrics, things that don't really make business sense, to things that makes economic and business sense, which would bring in both domain as well as economics together, right? So for this, the suggestion or from a design perspective, what we need to do from an overall solution perspective is treat economic SLOs. SLO stands for service level objectives, and service level objectives, we have mostly been looking at it from a technical standpoint, where we talk about, hey, is the system up for so long, or is the system kind of responding within X seconds, and it has always been a technical one. So what I am proposing, and in fact this is something that I have done in multiple engagements, is we bring in economic SLOs where we say, hey, how do we kind of look at the unit cost and tie it to the value and the domain that we are working at, right? And this is definitely going to help us bridge the gap that exists between the AI value realization and making it more meaningful towards the domain as such. Okay? And to make all of these things, see, the past governance mechanisms have mostly been manual and review driven, and it usually happens as a postmortem. And you kind of have a failure, and then you try to figure out why things fail, and then you come up with new design that gets implemented. So it takes a long time before a problem gets addressed. And in fact, if you look at the typical time frame it takes, depending on the agility and kind of nimbleness that your organization has, it could be anywhere between 6 to 24 months before these problems get addressed in the current state, right? So how do we get to a situation where this becomes more real time and we don't really have to wait for months together before I bring in the economic resilience? The practice that I have seen work well is make your architectural guardrails implementable through policy as code, right? So let's say, I think if you look at some of the top ones like Google or OpenAI and all of these guys, they have the right set of architectural interventions, and they tell you, hey, the requests that you have are going to exceed, or you get a dashboard that shows you how you are really from a quota perspective and all of that. They are able to do all of that because they have the right architectural foundations. And so your economic SLOs need to be part of the architectural guardrails, and it needs to be enabled at code level rather than becoming a policy that lives in documents, right? So for this, one of the things that I have seen work well is AI monetization framework, where we treat or we come up with a set of principles that talks about, hey, what gets covered as part of the monetization plan, which includes observing the cost and figuring out how do we go from measuring to kind of translating that into a pricing strategy. And if you are an enterprise, you can look at this more as a how do you do chargebacks to the individual units that you need to share the cost with, rather than treating it as a pricing strategy, right? So next comes the overlay, where we talk about, hey, how do I know the value that I'm trying to achieve from the business or domain perspective? how do I control from an economic standpoint, and how am I able to kind of ensure the trust is preserved. All of these are going to be the overlays that would help use the patterns that we have at the bottom. And if you look at the bottommost that we have, these are the systems that we build today. And these are the patterns that would help you to be able to get to a level where you have the control and be in a position to be able to get to the level of resilience that we are looking at from an economic standpoint. Okay? And the next one, I have just tried to summarize. So pricing awareness or cost awareness is really critical for architectures, right? And there are 4 pillars that we had looked at. Number 1 is make sure your architecture is pricing aware, okay? And it is able to build and instrument those things as part of the solution that you put in, and look at economic units rather than proxy metrics, because the proxy metrics are not really going to help you measure the value, and they don't really translate well as well. And economic SLOs helps you kind of look at economic SLO as a first-class non-functional requirement, which has not been a common practice across the industry, right? And governance by architecture, which is what I suggested in the previous slide, where we talk about having the policies implemented through code and be configurable in such a way that if I want to change something, I should be able to do it at runtime through an admin console rather than being going back to the design and development cycle, right? So these are, and again, if you are really looking at how do you make your economics legible, these are common questions that I generally ask. And some of the things see, if you look at the third one, which is about what behaviors are we incentivizing, is a very big challenge, and we generally forget about those. And this kind of leads to the fat tail problem, which has been a major cause for most of the pricing failures that we have observed in the industry, right? And this is just a sample set for you to consider when you are doing reviews. And the thing that I wanted to kind of emphasize is the architect's mandate is kind of expanding, and the old mandates were primarily technical in nature, looking at the structure, scalability, and reliability. Now the new mandates are more of economic in nature, looking at the cost boundaries and how do we help kind of contain problems that are economic in nature from happening, right? Architecture is now an economic discipline is the message that I wanted to kind of conclude the presentation with. So open for questions.
Yeah. Are you able to hear me?
Yeah.
Thank you. That was a pretty resonating session for most of us who are on this journey. Especially, like you said, we started with having very beautiful pilots for, especially for provider space, right? Patient care, the agents worked perfectly during the pilot phase. Right now, as usual, we are stuck with our RAG databases are not getting updated due to region constraints. The adjacent systems are not getting integrated to a variety of data challenges. So what I would like to know, if I wish I knew this earlier, technically, what do you think there are 3 or top 5 below the hood technical factors we should think about before pitching it to a very large, especially healthcare customer? And I'm talking about the provider side.
Okay. So, see, healthcare is definitely a challenging area, especially if you are looking at getting adoption from doctors.
Yeah.
And that is one of the domains where the cost of error is very high. When I say cost of error, say a decision, for example, if you are looking at, hey, is this ECG or is this echo kind of giving me a diagnosis which says this patient has to go through a particular procedure, and if the inference is not correct, it could lead to a life being lost, right? So this is a very, very sensitive area, and if you look at the Watson case, it was again healthcare use cases where the doctors did not really understand why recommendations are being provided and what is the basis through which the decisions are arrived at. Primarily the explainability of the suggestions that comes from your model, right? So unless you have an explainable AI model that tells you that, hey, these are the reasons and this is how I arrived at a particular recommendation or a set of recommendations that I am giving you, it is going to be very difficult, and especially when it comes to questions of life and death, it would be very difficult without an explainable AI solution, and it would take time. But if you look at other domains where the cost of error is very, very low, say for example, a recommendation system that talks about product recommendations, even if it goes wrong, I don't think it is really going to be leading to challenges that are life and death questions, right? So it depends on the domain. I don't have a solution other than making sure you have an explainable model that tells you why it came to a particular conclusion at this point.
Yeah. Thank you.
Okay.
So there are many of these. So suppose you are a small-time business person and you are actually using some of these cloud providers to, say, develop some product. Now there are a lot of other hidden costs which you don't realize. Now, how do they go about sort of trying to figure out how much they are going to spend, and when do they hit a plateau, when do they stop? What are the kinds of economic policies that they should sort of put in place? Because, okay, you may say, I'll take this GPU here, but then there are problems, because if your code is not written properly, then the GPUs are not utilized to the full extent. Now, so while you address the issues of providers at the level of the customers, how do they evaluate their economy?
Are you asking?
No, say you're a small company which is trying to sort of build some use cases and so on, but in developing those use cases, you are actually going to use say Llama, or you're going to say GPT 5.2, something you're going to use. Now, and to even make calls to this, you will either use Grok, you will use some cloud provider which will allow you to access these models.
Yes.
Now, there is a problem, and these cloud providers will tell you can use these GPUs, you can use these CPUs and so on. But there is always a problem of how much resource I can use, because if I have not written my code properly, then my usage is, my going through these cloud providers is a waste actually. But so at this end, how do you sort of, what are the policies you should put in place?
Okay, see, it usually starts with the budget that you are looking at, right? So, and I don't think cloud providers restrict you, and they only alert you when you are exceeding.
Yes.
So, they don't stop you from using more of GPUs or compute powers if you have a solution that doesn't have a bound.
Yeah.
So that is where it actually becomes a challenge, where the architecture that we put in place should really know what is the bound to which you want to allow. And that has to be part of the foundational structure that we put in place. So I know, hey, I have already consumed so much and I cannot really go beyond this because my monthly budget is X. And if I am at say 95% of that usage, I should stop and inform the user that, okay, there is a challenge, I cannot go further, and you kind of put that in place where you are measuring, metering, and then making decisions. So you have an economic engine that does that for you, and which is a gap that exists today.
Okay.
And that is where the monetization engine that I talked about, if you look at it, see, these are, again, cloud kind of would be at the bottom
Yes.
of your execution pane. And what we are talking about is, hey, how do we kind of get in all of these patterns that allows you to bring in the configurability where you can say, hey, if I have to have certain GPU budget, so you set that budget, and if there is going to be a limit that you want to hard set, saying that, hey, I cannot exceed, then these patterns will help you to kind of address those for you. Yes.
Thank you.
I think there is one question. We'll take that.
We'll take it during the break, sir.
Sure. Yeah, go ahead.
So that was a very interesting session. Thank you so much, sir, for this. Ladies and gentlemen, can we have a round of applause for that, please? Yes, we have Mr. Sukumar Rajagopal, sir, to felicitate the speaker with a token of gratitude. Thank you so much. So I know people still have questions. You can connect with him during the coffee break and have a great networking. You can probably shoot out your questions as well.